Okay. Hello. Thumbs up naman kung kita na yung slides. Thank you. Okay, let's start. Chapter 6, Magnetic Fields and Matter. Yung coverage ng exam nyo will be Chapter 4 to Chapter 6. And Chapter 4 was dealing about electric fields and matter. So this time, magnetic fields and matter naman. And we will discuss the things the same way we have discussed the electric fields and matter. Ang ganda nito kasi everything is para siyang uulit lang lahat. Okay? Okay. So when you bombard a okay, so wait lang muna. Ano muna tayo? Imaginein lang muna natin. Jello, what's the electric field inside a conductor?
0 to 2.
Okay, 0. A conductor is less than E medium is less than E vacuum. Okay? We have seen this in the electric fields in chapter 4, diba? Kasi si electric field in vacuum, this could be defined as the electric displacement divided by the epsilon naught. Vacuum. Tapos yung medium, pansin nyo that this is defined as epsilon for linear dielectrics, di ba? And we know E is greater than epsilon naught. Therefore, parang ang ginagawa ng medium mo is tinotone down niya yung electric field. Okay? Tinotone down niya yung electric field inside the medium. And in the vacuum, where kung saan free yung electric field mo, at its maximum power siya. Okay? And then, syempre, kapag yung medium mo per conductor na siya, nagiging zero out na siya. So, yung E mo nag-approach to infinity. Epsilon mo nag-approach to infinity so that the electric field becomes zero. So, in the same way, titingnan natin kung ganoon din ba sa magnetic fields and matter. Okay? So, from chapter 4, when you bombard electric fields, when you bombard material with electric field, ang mangyayari, di ba, nag-a-align yung mga molecules. Okay? Nag-a-align yung positive to negative na ano. So, kuwari, meron kang field E. Ang mangyayari sa molecules mo would be mag-a-align sila positive to negative. Mag-a-align sila sa field mo. Okay? So, may rotations na maganap. And in essence, nagiging polarized yung molecule mo. Di ba? Yan yung nagagawa ng electric field. Pinapolarize niya yung mga molecules para maghiwalay yung positive end niya and yung negative end niya. Yung poles niya. Okay? Sa magnetism, if you bombard matter with magnetic fields, in essence, the same yung mangyayari. Okay? Yung tinatawag tayong magnetic polarization, pero the fancy term would be nicer, magnetization. Okay? Sa magnetization, may tatlong bagay na nangyayari. Meron kang paramagnetism, diamagnetism, and lastly, ferromagnetism. Okay? Sa paramagnetism, what happens is that yung magnetic field mo, yung magnetic dipoles mo sa loob ng matter mo would align with your magnetic field. Align. Okay? With B. Pero sa diamagnetism mo, ang gagawin niya, kina-counter niya yung B. Counter B. Okay? So this one is parallel. Oops. Nice spelling. Parallel. Anti-parallel yung diamagnetism. Okay. Yung ferromagnetism, ito yung nakikita natin usually. But this guys, pero mahina lang tong dalawang to. What happens with ferromagnetism is that para siyang paramagnetism, but ang mangyayari ay magsistick sa kanya yung alignment ng mga bagay-bagay mo. Okay? So, aligns with B, but remains unchanged. Unchanged after B is removed. Okay, so pag tinanggal mo ngayon yung magnetic, di ba, binobombard mo yung matter with magnetic field. So, kapag ferromagnet siya, mag-a-align yung mga dipoles mo sa loob. And then, ang mangyayari sa kanya, mag-stay siya doon. Okay? Magiging magnet na siya. Kaya yung mga magnet niya is made out of iron. Kaya ferromagnet. So, sila yung best example ng ferromagnetism, iron. Kaya ferro yung pangalan niya. So, kapag binombard mo yung normal iron, kapag binombard mo ng malakas na magnetic field, yung iron mo, magkakaroon siya ng magnetic field inside na naka-align doon sa binombard mo sa kanya. And then after you remove that bombardment, it stays. Yung magnetic field sa kanya, it stays. So, nagiging magnet na siya. Nagpo-produce na rin siya ng magnetic field. Okay? So, like sa polarization, we talk about dipoles, di ba? So, physical manifestations nito would be charge and a charge. So, this time, we're talking about magnetic dipoles. And magnetic dipoles is a current loop na maliit. Okay? So, ito, meron kang tinatawag ka na P for your polarization. So, this time, meron kang loop of current. Hindi kaya ko mag-drawing ng bilog. Yan. Another one. Okay. So, kuwari may current loop ka na. May I. Tapos, meron kang area, small area. A. Then, meron kang dipole na pataas, which is defined as M, di ba? Magnetic dipole moment, which is I times A. Or, is actually I integral of dA, kung naaalala nyo sa last example, di ba? So, integral of dA, which is just the area of the loop, would be just A. Okay. Okay, so ang pinag-uusapan natin ngayon would be magnetic dipoles. Okay, and as before, we have discussed the torques and forces on dipoles. Okay, from last time, in-assume natin na hindi naka-align yung dipole mo. So, hindi naka-align. Kuwari ganito. Yung dipole mo, ganyan. Okay, so meron kang force dito, meron kang force dito. Okay, so iikot siya. So similarly, for this, okay. Try natin. Okay? Suppose meron kang magnetic dipole na pa-square. Okay, you can actually think of other shape, pero the results would be similar. Okay, mas madali lang i-discuss yung gantong shape. You can actually make it circle, you can actually make it some arbitrary shape. Ang point lang is that if you have a magnetic field pointing upwards, on the z hat, and then your magnetic dipole is at an angle between z with theta, okay? Tapos may umikot ka na current around that loop, makuha mo na, di ba yung torque ay natin, ay lumipat ng color, R cross F. Di ba? Okay, so sa side view, tingnan natin. Wait, isipin muna natin kung paano yung force. Naalala niyo pa ba yung force? Yung force ay mababother ako, ayaw niyo magpalit ng color. Force ay I dl cross B. Naalala niyo yung formula. Okay, basically, kung saan dumadalo yung wire sa DL, cross mo siya with B. Okay, so imagine niyo now, sa side na ito, sa side na to, ayan, napalit mo yung color niya. Pag ganun siya, dito downward, upward. Okay, so if you're gonna do DL cross B here, so cross mo to with B, ang direction ng force would be, for this side would be here, x hat, and for the other side, gawin mo yung cross product, ay yung, tama, yung cross product nito, tsaka yung B mo, that would point there, and these two would cancel out. Okay, magka-cancel itong dalawang to. Cancel to, tsaka ito. Okay, for this one, yung DL cross B mo, yung DL is going there, papuntang negative x hat. Tapos i-cross mo yun with z hat. So that would give you a force going y hat. And the other one is going this one. Okay, magka-cancel ba sila? No, kasi they are tilted at an angle. Okay? So iikot tong dipole mo, yung loop mo, so that the dipole moment would align with your magnetic field. Okay? So let's do this. Calculate natin yung R cross F. Yung R mo would be A. So same lang yung dipole moment between the two. So you have your dipole moment as A F sine theta. Yung theta ay itong angle na to. Okay? Kasi same lang to. Ito ay A. Tapos yung theta, same lang. Okay? Same lang yung angle na to. So the cross product would be AF sine theta. Then the direction would be x hat sine theta x hat. Okay? Okay. Now, what is F? F should be DL cross B. The DL for this path is B. Okay? A and B yung niya, yung dimensions niya. So, I, B, B. Okay? Since alam naman natin na yung DL, the path x in the x hat direction is always perpendicular with z hat. Okay? So, normal na multiplication na lang. Okay, so this is the magnitude of the force. Now I plug it in there. So N should be A times I B sine theta x hat. Okay. And then I know this guy. This guy is just I A B. And what have we said earlier? Na yung magnetic dipole moment mo is just always the current times the area of the loop na nabubuo ng current. Okay? And ito yun, di ba? I, tapos area ng loop, which is yung square mo, or rectangle in this case, if A is not equal to B. So we have this guy as your, M. So N, the torque, is just M, B, sine theta, x hat. Okay? Look at this. MB sine theta x hat. Cross product nito ay x hat. Okay? So in essence, this is just, we further simplify it as M cross B. Okay? Amazing. So that is your torque for your magnetic dipole. And look at the torque that is acting on an electric dipole. N is equal to P cross E. P yung ano mo, yung electric dipole mo, di ba? Electric dipole moment. Okay? Ang ganda, di ba? Very similar. Okay? And then the force, hindi ko na ito i-derive. Take it as it is. Pero may derivation siya sa isang problem sa libro. And it would be like this. Okay? So, for a infinitesimal dipole ito. Okay? May dipole ka, what would be the force acting on that dipole? You have this guy. And similarly, for the electric field counterpart, ito yung P mo, yung electric dipole moment, it's similar. Okay? So parang hindi ganyan yung nakita namin last time. Ano ba yung nakita natin last time? Ito yung force sa electric dipole moment, but of course, titingnan nyo sa likod ng libro nyo yung tawag dito, yung mga identities, you can find out that you can transform this into a more elegant, more nice looking equation like this. Okay? So that's nice, no? Na umuulit lang yung mga bagay-bagay. Okay? So that's one. Ito yung tinatawag natin paramagnetism. Nag-align yung dipole mo with your magnetic field. Okay? Now, tignan natin, no? Let's look at this. Magnetic field and atomic orbits. So, sabihin natin meron kang electron that is rotating, revolving around a proton. Well, hydrogen atom. Okay, pero let's say for an arbitrary molecule, this happens. Okay. So, this happens for an arbitrary molecule. Na meron kang clump of positively charged particles in the nucleus, then some valence electrons revolving around your atom or molecule. Okay? Now, syempre, so, yung R mo, sabihin natin circular to, no, for the sake of argument, yung R mo is very, 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 very small. Okay? Very, very small yan. And you would have your, isa lang electron mo, umiikot siya around this counterclockwise. Pwede mong isipin that that electron would constitute a current. Okay? So may current tayo dito, kunyari, okay? Na umiikot siya. Para siya maging dipole for a magnetic dipole. Okay? Pero in general, okay, in general, you say that you have a Q going to this direction. This does not constitute a current, okay? Kailangan lambda, yung minimal natin na gusto natin, lambda V dapat yung line current mo, okay? Okay, so dapat line charge siya in general. But if it's very, very small, kuwari ganito nga sa atom, you could say that your Q, revolving Q, would of course have would constitute a current. Okay? Okay ba yan? Okay. So, tingnan natin kung paano natin maka-calculate yung current. Okay? Okay. Suppose that your the velocity is given for your the velocity of the particle is given v. Then you know that the time required for that particle to revolve around the circumference of the circle of this orbit is given by 2 pi r over v. Okay, tama, 2 pi r over v. Okay, tama, di ba? Distance over time. Okay, so time mo ko. Okay? So, para makaikot yung period na kailangan mo para makaikot ka dito, given that you're running around at v, is given by this guy. Then the charge, the current, I could say that I is Q over T, the time that I need. So that would be negative E dahil electron siya. Then the time is 2 by R V. Okay, that is my current. Okay, what's my magnetic dipole moment? The magnetic dipole moment is M, it would be the current, tapos A. Okay, the current, I know that, this, tapos yung A ko would be pi R squared easily. So I write down things, 2 pi R, then times pi R squared, yes, squared then. Okay. This is your current, this is your current, then this is your area, and in essence, this is negative E V R over E V R over 2. Then the direction would be Z hat. Tama? Okay. Pansinin nyo na downward yung ano, no, magnetic dipole moment. Kasi even though rotating siya at counterclockwise motion, kung right-hand rule ka, pataas dapat, along Z dapat. Diba? Along Z hat positive dapat. Pero, the charge is negative. So, nag-flip down yung magnetic dipole moment. Okay? So, pababa dapat siya. Okay. So, nice. Nakuha naman natin ang pababa siya. Okay. Now, kung papansinin mo, kung mag-bombard ako dito ng magnetic field B upward, B, okay. From last time, di ba inisip natin na pag binombard mo siya ng B, mag-a-align dapat yung M at B. Okay. For this time, sometimes masyadong mataas yung energy required to do that. To flip this over, this whole thing over. So, ang nangyayari, yung electron nagko-compensate. Bumibilis siya or bumabagal siya. Somewhere like that. It has to change in velocity. Okay? Kuwari, itong molecule mo, random molecule mo, naka-lock in place siya. Say it's a metal, may same setup na ganito. Okay? Hindi siya pwede mag-flip, di ba? Hindi siya pwede mag-flip. So it has to have its electron speed up or slow down. Okay? So tingnan natin ngayon kung ano mangyayari doon sa electron. Will it speed up or will it slow down? Okay. So how do we do that? The force. Tingnan natin yung force, di ba? The force that is holding up this setup would be, of course, the Coulomb. Suppose wala muna tayong magnetic field. So we have 1 over 4 pi epsilon naught. Tapos E squared over R squared. Tama? This is the force, tama? Pag tinanggal ko yung isang E, electric field na lang yun. Pero pag multiply ko pa ng isang E, that is your force. Okay? And this should be equal to the mass of the electron times velocity over the radius, mv over r. You know this, if naalala niyo pa sa classical mechanics, mv squared over r, sorry. mv squared over r. That would be your centripetal force. Okay? Which is, ang pangit pala nung yung term na centripetal force. But anyway, you get the idea. Okay? So you get the idea. So we have this if we don't have the magnetic field yet. Okay? Now suppose we open up the the magnetic field, I'm sorry. The additional force na mangyayari, and that would be, di ba yung force ng magnetic force ay dl cross b. Okay? Or sabihin natin yung force na lang ng ng charge would be qv cross p. Okay? qv cross b. So q, you know q, that would be negative e. Tapos velocity is around xy plane. So that is always perpendicular to the upward magnetic field Z. Okay, so yung QV cross B ko would be a normal multiplication. So I'll add sorry, I gumalaw. Yan. E V cross B. Tama. Okay. Ano yung direction ng V cross B? So V cross B. Okay, outward yung effect nung outward yung effect ng V cross B. Tama, V cross B. So that's radial. Tapos, ina-negative mo siya kasi you want wait lang. You want your force to be inwards. Inward to, di ba? Wait lang. Parang di magandang Parang di magandang argument yun. Okay. Okay. So, again, perpendicular na agad si V at B. So, let's just write that down. V. Now, V, of course, is a new velocity. Isama ko na yung negative sign there. Okay? And then, the other side, of course, remains the same. V squared over R. Okay, so this is the forces that holds up the orbit. Okay? Okay. So now let's try to subtract this two things. Tingnan natin yung change in velocity. Okay? Okay. So we have magka-cancel lang yung first term. Okay? EVB tapos ME over R then V bar squared minus V squared. Okay? Tingnan lang natin tong change in the square of the velocity. Okay. Now you have V squared minus V squared is equal to R E V B E. Now you try to solve this down and expand in oh my god, binomial expansion. Okay, so we set things up. Ang lalabas dyan, if you would assume this guy is very small, yes. Okay, so sorry, nakalimutan ko yung term binomial expansion. Okay? You would actually have something like this. So yung change mo in velocity would be over 2ma. Okay? Okay. So, pag nagbago yung velocity ng system mo, yung rotating charges, in essence magbabago din yung period mo, and then magbabago yung current mo. Therefore, magbabago yung magnetic dipole moment. Okay? So, if we have a change in the magnetic dipole moment, we have delta V R over 2 Z hat. Okay? So, we plug in delta V, the change. So, RED over 2NE. RED over 2NE for NE. So, this is actually negative E squared R squared B Z hat for NE. Okay, anong point dito, no? So kung wari kahit hindi mo sabihin tong part na to, kung wari tinamad ka gawin to, or in essence hindi mo talaga ma-approximate, very small yung change, the point still remains. Nagkakaroon ka ng change in dipole moment, which still points at Z hat, negative Z hat. Okay? So kapag binombard mo ng magnetic field yung isang dipole na tulad na binombard mo ng dipole yung isang dipole na tulad na ito, ang mangyayari, magkakaroon pa siya ng extra dipole moment downward. It is as if that the dipole is counteracting this magnetic field. Okay? Amazing, di ba? So, ayun yung diamagnetism. So, bakit niya kinokontra yung magnetic field? Ayan yung essence nun. Okay? So, for different molecules, nagbabago-bago, no? Hindi, mahirap ma-generalize, okay? Kung alin yung paramagnetic, alin yung diamagnetic. Okay? So, you have those properties. Alright? Okay. So, amaze, di ba? Amaze. Alright. Next, we have, tuloy tayo sa magnetization. Okay? From last time, di ba meron tayong P, small p, that we can write down as capital P. Okay? Capital P with the would be the polarization, and that would mean the electric dipole moment per unit volume. This time, similar thing happens. For magnetization, we have M, which just says that the magnetic dipole moment per unit volume yung nare-represent niya. Okay? So, very similar to your capital P. Okay. Then next, we will, of course, study the bound currents. Yung similar nito from last time would be the bound charges. Diba? Okay? For this time, gagamitin natin yung A, yung magnetic vector potential, kasi di ba nasulat natin yung magnetic vector potential in terms of the multiple expansion. So, multiple expansion, makukuha mo na agad dun yung dipole term, which is this guy. Okay, so we use this equation. Okay. For this, okay. Since again, si M, capital M ay dipole moment per unit volume, i-integrate mo to with the total volume, you get your m, small m. Okay? So kapag binreakdown mo sa maliliit, magiging ganito siya. So far, tapos ka na dapat, pero we want things to look nicer. Okay? So since we have this equation, you can write down r hat over r squared, curly r hat over r squared as this thing, as the gradient of 1 over curly r. Okay, select natin para tayo malito. Oh, sorry. So you have mu naught over 4 pi, then m cross del prime of 1 over beta. Beta. Okay, then use this identity. Ito yung meron ka, di ba? Mapansin nyo dito, gradient ng, ito yung f mo, yung scalar function, tapos yung m mo would be your a here sa identity mo. Then you can find out that if you're gonna do this, you have your f, which is 1 over curly r, then del cross a, which is del cross m, minus this guy, del cross yung function mo, 1 over r times a, which is yung m, so m over r na lang, would be this guy. Okay, now, there is a, sa gradient, divergence theorem mo, di ba? Ang divergence theorem would look like this, something, bitaw, tapos i-equal mo siya something, dA. Okay, so that's your divergence theorem, and Stokes theorem would be something like this, the dA, then dL. Okay, so ganyan yung itsura ng mga theorem mo. So divergence theorem, tingnan natin divergence theorem, kasi napansin natin ng d tau naging dA. So actually, this is just divergence theorem but a special case one. Okay? So alam mo na yung divergence theorem that the terms inside this parenthesis would be divergences. You could actually set, magsiset ka lang ng other constant mo na maging cross product siya. Kuwari del dot v. You'd say that v is function that is defined by a cross b, then you would actually end up something like this na equation. Okay? So, nasa ano yan? Nasa libro, tingnan nyo na lang. Nasa problem yan sa 1 point something. Okay? But the essence is the same. Nahugot lang ito sa divergence theorem na kung saan yung mga divergences ay pinalitan ng curl ng dalawang vector. Okay? Okay. Hindi naman namin ito papaderive sa inyo. And this is just 130. You just have to have a feel of what we are doing. Okay? So, ayan. Similarly from last time, sa mga bound charges, di ba, nagkaroon ka ng dalawang terms lang din. Tapos, sinabi natin that these guys, the things that are inside the parenthesis, would be the bound currents. So last time, bound charges yung pangalan nila. Si rho at sigma. Di ba? Rho B tsaka sigma B. So this time, kung maalala nyo, si rho B ay negative del dotted with. Okay? And then si sigma B ay E dotted with N. Okay? Okay. So dito, the first term, del cross M, is just your bound volume current, J. Then yung M cross dA or M cross N hat, tapos iwalay mo na sa dA, would be the bound surface current. Amazing, di ba? Okay. So you can write down this magnetic vector potential as this guy. Very neat. Okay? Galing. So example tayo. Find the magnetic field of a uniformly magnetized sphere. Sabihin natin yung magnetization niya ay pointing z hat. Okay? Okay. Though, ang mangyari? Ano na mangyari? Yung JB mo, of course, uniform ang magnetization. Ang derivative ng uniform ay 0. Okay. What's left is M cross N hat. So, you know M is just, so lagay natin, KB. K yan, capital. Is equal to, sabihin natin M yung magnitude ni magnetization, then Z hat yung direction niya. Cross, yung N hat mo, saan galing N hat? Sa surface. Okay, so sphere ito, so spherical yung surface mo. Ano yung, oh my God, what happened? What is N hat for a sphere or hat? Okay. Z hat cross R hat. Okay. So, gawin natin ang Z hat cross R hat. So, Z hat cross R hat is just R hat, theta hat, tapos V hat. Ang Z ko would be cosine theta minus sine theta. Cosine theta cos theta minus sine theta. 0. R hat ko would be 1, 0, 0. 1, 0, 0. So therefore, ang magsusurvive lang na term ay phi hat. And that would be positive. Okay? Positive sine theta phi hat. Okay. So M sine theta phi hat. Is that what we got? Okay, so we have your K as some M sine theta phi hat. So if you have a surface current, you have a bound surface current that is going around your sphere. Kasi di ba ang phi hat mo ay rotation around the equator of the sphere. Well, not necessarily equator, pero all that parallel with the equator. Okay, so nagro-rotate siya around z-axis. Okay? Okay, tingnan natin ngayon yung previous example natin na okay. Spherical shell of our radius r carrying a uniform surface charge tapos spinning at velocity omega. Okay? Mapansin nyo na ano ba yung K natin dito? Basta ang K mo dito would be spinning around phi. Okay? Spinning around phi. And similarly, you have a current here, surface current, that's also spinning around phi. Therefore, hindi na natin uulitin yung mga solutions natin before. So, alam na natin to 0 agad to. Tapos, for this guy, sinolve natin yung from previous example na this would actually produce a spinning, ito pala yung result. Okay, ito yung result from the previous example. Sigma V, di ba? May sigma ka tapos nagro-rotate siya. Okay. Napansin nyo, phi hat din yung direction niya. So, compare mo to dito. You see that M is equal to omega R. You can say that, okay? Parang similar na sila. Similarly patterned sila. Okay? And then if you want to make it a vector, sabi natin si z hat yung omega mo, ay yung si z hat yung M mo, yung magnetization mo, then you would see that it's also rotating at omega. Okay? So anong point natin? Ito yung result ng previous example. Okay? So B, this time you can have it like this. So omega R sigma, that would be your M. Okay? So this is the magnetic field for a uniformly magnetized sphere. Now, not necessarily na ito yung laman niya, okay? Ang point lang is that whenever you have a surface current K that is rotating at the surface of your sphere, it would have this result, and then you can write this as this much, okay? Sabihin man na iba yung value ng magnetization niya, you can just plug in directly at here. Okay. Okay. Now, what does this two surface currents, bound currents physically mean? Okay. So lahat ng dipole mo inside a chunk of matter. So this is a chunk of matter. You would see that magnetization mo ay upward, therefore yung mga maliit na currents mo would be like this, di ba? Okay? Kasi si M ay magnetic dipole moment per unit volume. So you have this dipole moments na loops. Okay. And mapapansin nyo na ito ay downward, ito ay upward. Okay. In essence, if these are all the same, if the magnetization is uniform inside the chunk of material, you would see that all the inside currents cancels out, and yung magsusurvive na current would be those that are on the edges. Okay? So, in essence, ito, mag-simplify mo siya as something like this. Okay? May nagro-rotate na current. Rotate na current sa kanya. Okay? So, amazing no, na yung may current sa kanya pero the charges don't revolve around it. Okay? So, yung mga charges mo, umikot lang sila dito. Umikot lang sila dito. Pero yung macroscopic effect niya would be producing a current that revolves around the whole thing. Okay? Okay. And that's nice, no? At this edge, ang makita mo is n hat. Okay? Okay, tapos yung magnetization mo upward. So kapag kinuha mo yung cross product nito, makukuha mo yung current na pagano, di ba? And that current is this guy. And that current is also K. This is surface current yan. Rotating around K. Amazing, di ba? So yung K mo, that is your M cross N. Sir, paano naman yung mga nandito na N hat? Diba parang ba't natin pinili agad yung edges na N hat doon sa gilid? Okay, so pag kinuha mo naman to, walang cross product to kasi parallel sila. So yung magkakaroon lang ng cross product would be this N hat. Okay, so mga nasa edge. Okay. Nice. All right. Now, that is for uniform chunks of magnetization. How about yung mga magnetization na hindi siya uniform, bali nagbabago-bago yung mga current na to, maliliit na current. That would mean na hindi magka-cancel out yung mga maliliit mong current sa loob. Okay? Hindi sila magka-cancel out. And in essence, tanggalin natin yung mga sulat natin. Makikita mo na may current ka na umiikot around it. Okay? May current ka na umiikot sa loob. Okay? So may current ka na around this, revolving around the entirety of the chunk. Okay? And that is del cross M. Del cross M. But how do we imagine this del cross M? Parang hirap naman yan, sir. Okay, sige, balik tayo sa mga alam natin na mga bagay. We say that B is a product of the curl of the magnetic vector potential. We know that the magnetic vector potential is parallel to your currents, I hat. Okay? So whenever, di ba meron tayong line current? Kaya may line current tayo, I. Then the magnetic field would be the right-hand rule. Okay? So, ganyan yung mga magnetic field mo. Around it, circles around the loop, in the circles around your current. Okay. So, also, sulat natin that red is parallel to that the magnetic vector potential A is parallel to your current. So del cross A would mean that B is just a circle around your current. Okay? Kung naaalala niyo yung solenoid, ano yung itsura ng solenoid? Ang solenoid would be currents circling around. Drawing tayo ng cylinder. Okay? So, solenoid naman, tingnan natin. Meron pang current na umiikot. Color-coded tayo, no? Alam natin na green yung current. Okay? So, ganyan yung rotation ng current mo. Then the field that this produces is a line or lines. Pero straight lines. Ang point ko is straight lines. That's your B. The I. Ito. Tapos alam natin si A ulit, di ba? Si A ulit ay bibigyan niya tayo ng direction na parallel with your current. So your A actually is the same like your current. Okay. Done with it. Okay. Okay, so this is your A. And then if we get the curl of A, so pag circular na yung circular na yung kinukuhanan mo ng curl, lumalabas line. Okay. So now we have the mechanism, or we can now imagine what del cross M looks like. Okay? Okay. So del cross M would look like, since this M is upward, if M, po tayo na ibang color, blue na lang. This is your M, then your del cross M would be something like this. Okay? This is your del cross M. Okay. So del cross M is something that rotates around your magnetization. Amazingly enough, tingnan nyo dito, sinabi natin na kapag hindi pantay-pantay yung mga currents, meaning infinitesimal currents sa loob ng chunk mo, you would have your current somewhat rotating around your chunk. Okay? So that would be defined by del cross M, di ba? Kasi nagro-rotate to green lines mo dito sa M. So that would be your J. Okay? That is your bound volume current, del cross M. Okay. So yun yung ganun yung siya i-imagine. Galing, di ba? Okay. Nice. Okay. Now let's proceed. Di ba? Okay. This is fun. I like this. Okay. Di ba sa electric field mo, meron kang tinatawag na electric displacement. Okay. So this time we have B. And that would be related to your auxiliary field H. Okay. So then let's derive this H. Suppose your volume charge or volume current, nakakalito, di ba? The volume current J can be separated into two. So you have your bound and the free. Just like last time, for the electric fields in matter, you know that rho can be separated down into rho B and rho F. So rho F basically is just your other charge distribution that is not bound. Okay? So yun lang definition of free. Everything that is not bound is free. So same dito, same. So JB is your bound and JF is your free. Now Ampere's law gives us del cross P is mu naught J. Okay. So factor mo lang yung mu sa kabila para J na lang sa kabila. So this guy, ito yun. So that is J. Now we have said that we can separate the two, JF plus JB. Then JB, sabi natin that is just del cross M. Del cross M, lipat ko sa kabila. Lipat ko to sa kabila, that would be minus del cross M na siya. Then I could factor out a curl. Factor out a curl. This would be the resulting equation. Tama ba? Okay. Now, we write down this whole thing in the parenthesis as your auxiliary field H. 1 over mu naught B minus M equals JF. Okay. So, del cross H is just your JF. So, bakit natin sinulat ng ganito? Para masulat natin siya as an line integral for your Stokes theorem. And you find that the closed integral for the loop of for the dot product of h dot dl is just I enclosed, IF enclosed. So this is your Ampere's law. Okay, modified Ampere's law. From your last time, electric displacement, meron kang modified Gauss's law. Okay. This time, meron kang modified na Ampere's law. That is for your auxiliary field. Okay. So how do we do this? Let's try an example. So a long copper rod of radius r carries a uniformly distributed free current I. Pipe H inside and outside the rod. So, kunwari may rod ka daw na may current I. Okay? Okay. So, isip ka lang ng Amperian loop. So, you know agad na H is parallel to your B. Okay? Parallel to your B. So, you know from this setup that B is rotating around your current. Okay. So, therefore, your auxiliary field H should be the same thing. Okay? So, uniform yung distribution ng current I. So, if we try to get a smaller Amperian loop here inside, then the prescription would be H tapos 2 pi s, the circumference of this Amperian loop, then that must be equal to IF enclosed. IF enclosed. So IF enclosed is just na-enclose mo dito sa part na to. Okay, but alam natin na uniform daw yung distribution, so that would mean that ang makukuha ko lang in this circle would be the area, a portion of the area. Tama? Kung R ito. R. Okay? So ito yung I enclosed ko. So H would be just cancel. I s squared. IS na lang pala. IS over 2 pi R squared. Tama ba? IS over 2 pi R squared. That is for S less than R. Outside, that would be very easy. Outside, similarly, ang kukunin mo lang na Amperian loop, same pa rin, 2 pi S, circular. Then, the I enclosed would be the total that is enclosed. Diba? Kasi malaki na yung loop mo. Ito na yung Amperian loop mo. So, totally, makukuha mo lahat yung nagpa-pass-through sa kanya, which is yung prescribed na I, na given. Okay? So, H is just I over 2 pi S. Phi hat. Okay? Okay. Amazing. Now, can we get the field inside? We can't get field inside kasi we would need your M. Okay? So, wala naman sa ating binigay na magnetization. So, H is equal to 1 over mu naught B minus M. So, kung hanapin mo si B, you just have to transform this into B is equal to mu naught H plus mu naught B, mu naught M. Tama? And if you don't know M, you can't solve this yet. Outside, amazingly, outside, B outside, we can solve that. B out is just mu naught H. Kasi the magnetization outside, wala. Kasi wala namang ano dun, wala namang material dun. Vacuum lang. So we have, what would be the magnetic field here? Di ba alam natin to na yung linear na current would give us something like mu naught I over 2 pi s. Naalala nyo? Okay, so tingnan natin kung ganyan ba makukuha natin. So mu naught, what's the outside auxiliary field? I over 2 pi s. I over 2 pi s. Checks out. Amazingly. Yeah? As it should be. Galing, di ba? Amazing. Okay. And of course, to check the things that you are doing, there you have your boundary conditions, which are these guys. Okay? So yung perpendicular component, that would be proportional to the difference in the magnetization on the perpendicular part of the magnetization. Okay? And then the parallel component to the surface would be this amount. Okay? All right. So that's it, no? So that's it for, meron pang katuloy ito. Meron pang, I mean, may next lesson pa to sum it up. So reading assignment would be a deceptive parallel. Kasunod lang. Wala lang, kung curious pa kayo sa iba't ibang bagay na related to the matter. And then prob set, para matry nyo gumamit ng auxiliary field H. Okay. So ano sana mapalabas, baka ibigay ito ni Sir Baguno, malay at least sasagutan nyo na. Okay. Sir, ginamit nyo ba yung boundary conditions dun sa... Mamaya. Okay. So any question? Wala. Okay, in essence pala, okay. In practice, in practice, the auxiliary field H, yung mas ginagamit in real life, no? Kasi yung H, dependent siya sa free currents na ibibigay mo. And free currents is yung not related to magnetization. So if you're gonna run down a current into your electromagnet, it would produce an auxiliary field H, diba? And you can control the current, basically. Okay? So, sa experiment, mas ginagamit si H. Tapos may mga ibang scientists na gusto na lang tawagin si H as your magnetic field. But, no. Mas cute na tawagin magnetic field si B. Okay? Tapos, as compared dun sa electricity, di ba sa electricity, ang counterpart nito ay electric displacement. Hindi ginagamit sa electric displacement sa experiments. Actually, sa electric field nga rin, parang di ginagamit sa as a measurement in experiments. What we need sa experiment is potential difference, di ba? Yung saksakan mo sa bahay, 220 volts, that's already a potential. You calculate the potential, you calculate the field, and in essence, makakalculate mo yung electric displacement. Okay? Diba? Parang dali, diba? Pero in essence, in practice, di sila ginagamit. Kasi, ang kailangan mo yung potential. Mas madali siya ma-measure. Okay. Okay, so let's stop share. Oh, bilis natin natapos.